Today we are going to be discussing physical and chemical properties. Different kinds of matter have different properties. A physical property is one that a substance displays without changing its composition. So it's just a change of phase, solid to liquid, liquid to gas. A chemical property is one that the substance displays through changing its chemical composition. The difference in physical and chemical properties. The characteristic of odor of gasoline, we learned this in the last chapter, is a physical property. Gasoline does not change its composition when it exhibits odor. The flammability, however, of gasoline is a chemical property. Gasoline does change its chemical composition when it burns. Let's look at water. The atomic or molecular composition of a substance does not change when it displays different physical properties. So if you look at water, for instance, boiling of water is a physical property and it boils at 100 degrees. When water boils, it changes from a liquid phase to a gas phase, but it is still water. You have two H's and one O. So here is a picture of that. This is boiling water in like a coffee pot. And you can see here you have little H2O molecules that are in the liquid. And when it boils, it goes into the gas phase, but you still have little H2O molecules. So the chemical is still the same. So changes of state are physical changes. So if you go from solid to liquid, liquid to gas, solid to gas, those are all physical changes. In a physical change, matter will change its appearance but not its composition. So when ice melts, it looks different, but its composition is the same. Since ice and liquid water are both composed of water molecules, so melting is just a physical change. Okay? In a chemical change, matter does change its composition. So an example of that would be copper turns green upon continued exposure to the air. But because it reacts with the gases in the air to form new compounds. This is considered a chemical change. Your starting substance is destroyed and a new substance is formed. All right, so here is this example. You have the iron 3 oxide, which is rust, and it started out as just iron atoms, okay? So you had iron, you move to this, starting substance is destroyed, you have a new substance formed. All right, matter undergoes a chemical change when it goes through a chemical reaction. In a chemical reaction, the substance present before the chemical change is called the reactants. And then after the chemical change is described with the reaction arrow here. The ending product is the products. The difference between physical and chemical changes, just to sum it up. A physical change is the atoms that compose the matter do not change their fundamental association, even though the matter may change in appearance. In a chemical change, atoms do change their fundamental associations, resulting in new matter. So in a chemical change, the starting substance is destroyed and a new substance is formed. If you look here at vaporization, so this here is a lighter. You have liquid butane in the lighter. If you just push the button here without lighting it, your liquid butane will escape into the air into gaseous butane, but it is just still butane. This is an example of a physical change. Now, if you actually light it, okay, you have your liquid butane here, but then once it is burned, your liquid butane turns into carbon dioxide and water molecules, okay? And so it has undergone a chemical change. The starting substance of butane is destroyed and a new substance is formed. That's a chemical change. All right, this is just showing a distillation process. So you start with a liquid, they turn it into a gas, and it goes through the gas phase, and they can turn it back into the liquid and recover back the same liquid that you had to begin with. This is just something going through a physical change. Filtration is when you have a mixture of a solid and a liquid, you can separate them by putting them in a funnel through filter paper, and you can keep the solid in the filter paper and the liquid in the flask that is collected. All right, the law of conservation of mass. Matter cannot be created or destroyed in a chemical reaction, okay? So what you start with, the amount that you start with, you're going to have that same amount to end with. Now, in a nuclear reaction, significant changes in mass can occur. In chemical reactions, however, the changes in mass are so slight that they can be ignored. During physical and chemical changes, the amount of matter remains constant. So here's just an example. Let's say you have in your reaction 58 grams of butane plus 208 grams of oxygen. And if you add those up, that's a total of 266 grams. You put those in a chemical reaction and you create carbon dioxide and water, and notice you still have 266 grams. That there is the law of conservation of mass. Whatever you have on the left side after the reaction, you will have on the right side, okay? And that's going to be consistent. All right, in our next section, we will be going through energy, and I hope this video helped you out. All right, bye guys.